Okay, we're going to do two of the order of operations problems. The instructions are to simplify the expressions below. These problems kind of combine together all of the things that we've been learning from negative signs and exponents and the order of operations, all that. All that gets combined into a single problem. And there are practical reasons why you won't see anything quite this large on a test. Usually, not always, but usually you won't see anything quite this big. First off, if there is any sort of partial credit, this is a nightmare to grade. If you have any sort of class size at all, any large class size, each one of these people are probably the vast majority are going to make a mistake on. A lot of teachers make mistakes on these when they're working through it the first time, so that means that a lot of students are going to make similar mistakes or maybe even more. So what tends to happen is you have to go through line by line and grade these things. Also, you won't see these normally because if you're trying to test a specific skill, it's hard to make sure that if the specific skill is missed, that you're losing points for that and not for incidental things. So you have to be most teachers are usually very careful about what skills that they're actually looking for, what skills that they're actually testing, so you tend to see smaller ones, unless it's kind of a problem that's supposed to separate out people who are really comfortable with the order of operations from people who are mostly comfortable with the order of operations. So there are a lot of places to make mistakes on this one. If you made a mistake, make sure you know where it is. I'm going to walk through this pretty slowly. We'll go through the next one a little bit quicker. So let's start this out. Negative 2 to the 6th power minus a negative 8. The negative 8 is squared, minus 5 squared minus 4 times 2 to the 3rd power. The first thing we should look for is any sort of grouping signs like parentheses. Here I see some parentheses. I'm going to simplify everything on the inside, and I notice that negative 8 is already simplified. I don't do anything with this set of parentheses because it's already simplified. This squaring, this subtraction sign out here has nothing to do with the inside of the parentheses. This is already simplified here. I'm not going to do anything with it in this step. Over here, I do not multiply 4 times 2. What's in this set of parentheses is 4. That is already simplified. I do not do anything with this set of parentheses. I don't do anything with this set of parentheses because this is just a 2 on the inside. 2 is already simplified. I am simplifying the inside only. I'm not raising it to the 3rd power. There is multiplication here, but those are two separate things. Even if if two planets were close to each other, or a planet and a moon, for example, you can't easily go from one to another. This is kind of a self-contained moon-like thing, and this is a planet. It's hard to make that jump in between them. So we're going to go through the order of operations now in the E step. If we're using PEMDAS, this is the E step for exponents. So we're done with parentheses. Everything within the parentheses is simplified. Let's raise this to the 6th power. And remember that this is a negative on the outside. The negative sign gets applied in the multiplication step, not in the exponent step. There are no parentheses here. If there were parentheses, this would come out to be a positive number, but the grouping goes like this. It's 2 to the 6th power. 2 to the 6th power is 64. And then I'm going to leave everything else like it is. And what I'm going to do is I'm going to underline the step that I'm taking. So I'm raising 2 to the 6th power. And I'm going to copy everything else. So that negative sign gets copied. Here's 64. And I am subtracting a negative 8 squared minus 5 squared minus 4, that's in parentheses, 2 to the 3rd power. And then my next step is going to be squaring this guy right here. This negative sign is not part of the base. This one is. It's on the inside of these parentheses. This square belongs to the set of parentheses, not just the 8. So this is a little bit different situation than the first time. Negative 64 minus, and this blue underlining gets simplified to 64. Negative 8 times negative 8. I have a negative on the inside. It's an even power. It comes out to be positive. The blue part is positive. Ultimately, I am subtracting. minus, oops, I'm trying to simplify that. If you want to combine some of these things, you can, but just for the sake of completion and clarity, I'm going to show every single one of these steps that I'm taking. And then I have 5 to the second power. And again, this negative sign is not part of the base. There are no parentheses around it. It's going to be evaluated to negative 64 minus a positive 25. So I'm still taking away 25. And then I subtract 4 times 2 to the third power. Let's see, do I multiply these? No, I'm going to raise this to the third power. If it helps, I can draw a little multiplication dot in between those things to separate them visually. So I am exponentiating here. I am not multiplying. Do not multiply those together. This is the step that I'm oops, I'm trying to do too many things at once. That's in my next step. 4, 2 to the third power. Okay, now I am exponentiating here. I am not going to multiply. So I write negative 64 minus 64. If I make a mistake at some point, it's very easy for me to fix my mistake because I'm only changing one thing at a time. I can actually follow it along pretty easily. Times 8. Okay. I'm done with the exponents. Now I move on to multiplication division. I only see one multiplication, so that happens next. Negative 64 minus 64 minus 25 minus, and this gets evaluated to 32. Now at this point I am going to kind of cheat a little bit because I know that if I have a negative 64, here's 0. I can think of this like a thermometer. Negative 64 is way down here, and then if I subtract 64, makes it even colder. Subtract 25 makes the temperature even colder, and subtracting 32 makes it even colder. So it's like I'm adding all of these things, but in the negative direction. I know I'm eventually going to have a negative number, so what I can do is I can just add 64, 64, 25, and 32. I would get 185. And I know it's going to be negative because all of these are negative. This would be a very cold temperature. So negative 185 is the number that you should have ended up with. Okay, let's work on the next problem. Negative 7 plus 13 minus 48 divided by 12 times 8 minus 6 in parentheses raised to the second power. Now, there are a lot of places to make mistakes. If you're working from left to right, this is going to give you a completely wrong number. We need to start with parentheses. The difference between this and the last situation is what is inside the parentheses is not simplified. 8 minus 6 can be further simplified to 2. And then I just copy everything around it. Negative 7 plus 13 minus 48 divided by 12. And then this is being multiplied by 2 squared. And then my next step is going to be to do the exponents. I do not do 12 times 2, I do 2 to the second power. So negative 7 plus 13 minus 48 divided by 12 times 4. And those parentheses actually didn't change, so let me keep those the same color. And alright, if we're getting tunnel vision here, we might try and multiply 12 times 4. That is incorrect. Do not multiply 12 times 4 at this step. Remember that multiplication and division happen in the order that they occur, left to right. I see addition, subtraction, I see division right here. So if you multiplied those two together, you may have gotten a little tunnel vision. That's the way that this problem was set up, and that's what this problem is specifically trying to test. Do you actually restart? Do you think of this as a completely different problem from the one above? You should be separating it out. Don't get that tunnel vision. Don't just go with the flow on this. Look at each one like an entirely new order of operations problem. We're starting out with negative 7 plus 13 minus 48 divided by 12 times 4. If I look at this as completely new, I see this division right here. Negative 7 plus 13 minus 48 divided by 12. 48 divided by 12 is 4, just regular old 4, and I am subtracting it, and then I'm multiplying by 4. Multiplication step's not done. I have multiplication right here. It's the last one, so from here on out it's addition, subtraction, and addition, subtraction works the same way. I am going to add and subtract in the order that I see it. I see addition here before the subtraction, so I'm going to add these two. I get 6, and then, I get 6, and then I subtract 16, and then that will give me my negative 10 as my solution. If you got 10 here, you got into a little bit of a hurry, so if you're doing that, slow it down a little bit. Check your answer with a scientific calculator. Remember that you can use a scientific calculator as long as it doesn't have fractions, and as long as it doesn't do any other weird stuff like it doesn't have symbolic manipulation and all that. You should be able to just kind of plug it in. Make sure you're plugging in your parentheses where they're supposed to go, and scientific calculator will follow the order of operations. A 4-function calculator, one that you get for like 10 cents or in a cereal box nowadays, those cannot do the order of operations. So this is the answer that you should end up with when you check your answer as well. Remember, you should have enough time to check your answers on the test.